Welcome to my YouTube channel. Today I'll be discussing new features for the security system with schematic details and a breadboard prototype demo. I will also be discussing a critical resistor value change in the Genie Board circuit presented in previous videos. When I was designing the security system, I purposely left out what is usually a standard feature in most security systems because I did not need the feature for the first installation. However, to cover every circumstance for the security system, I added an arming bypass timer. Whereas after arming the system, there's at least a minute before the security system will read any sensor changes, meaning any sensor can be activated for up to a minute without triggering the alarm. This feature can be especially useful if there is a sensor between the place where you arm the system and the place where there is an exit. The arming bypass timer in this security system is optional, whereas a momentary push of an external button is required to start the bypass timer. In version 3 of the following security RF circuit schematic, since I covered everything in this schematic in previous videos except for the arming bypass timer circuit, I will only comment on the additions. At the top, near the center, I added another 555 timer, wired nearly the same as the other 555 timer covered in my security circuit with auto reset video. I then added another transistor to create a NOR gate, of which is not OR, meaning if both of these transistors are off, the other transistor will turn on and activate the alarm. To activate the arming bypass timer, pin 6 was added to the header, of which when wired through an external push button to ground, and then the button is momentarily pushed, the 555 timer will start and bypass the alarm circuit for a calculated period of time determined by the resistor and capacitor values in the RC circuit. While the arming bypass timer is a temporary bypass for the hardwired zone and wireless zone, to unarm the system for longer periods of time, for example when you plan on staying in the house or building and want to leave the security system on, an external toggle switch for the hardwired zone can be wired in parallel with the hardwired sensor series between pins 4 and 5. And then to bypass the wireless zone, rather than opening the cabinet and turning off dip switches, I added pin 7, where an external toggle switch can be wired between pins 4 and 7 to bypass the wireless receiver. Regarding the critical resistor value change in the Genie Board circuit, in a previous video I discussed how the voltage at the Genie sensors and the voltage at the voltage divider is compared to comparator A, and while I had previously stated I was using a 2K and 10K resistor equaling 10 volts as suggested from the following bench test demo, after the Genie sensors were not blocked, the Genie sensors were clearly below 10 volts. Since the Genie sensors were only an inch or two apart, before the Genie sensor installation, I decided on a more practical test and spread the Genie sensors out more than 10 feet, and then discovered the voltage at the Genie sensors started to fluctuate between 9.9 and 10 volts, meaning the alarm could potentially activate when the Genie sensors are not blocked. I then reduced the 2K resistor in the voltage divider to 1.5K, of which calculates to 10.4 volts at the comparator, of which is in the middle of the lowest unblocked voltage and highest blocked voltage that I observed. This inevitably worked out fine, while the system has been running for days without any issues. While some might suggest a potentiometer, unless using a carbon potentiometer, the cheaper potentiometers can become unreliable depending upon the position of the wiper contact on the coil, since the wiper contact position can affect how much heat the potentiometer must dissipate. This is another example where practical field testing for quality assurance is more worthy than only bench testing. In the following demo, the sequence of events and key observations are a little different than in previous videos. Whereas in previous videos, I would first block the Genie sensor beam. In this demo, I will first press the push button to activate the arming bypass timer, represented by the blue LED. After activating the alarm bypass timer and then blocking the Genie sensor beam, the red LED representing the alarm does not turn on, and will not turn on until after the blue LED turns off, and then I again block the Genie sensor beam to activate the alarm. For video purposes, I changed the RC circuit values on the breadboard to reduce the time on the 555 timers. Since the blue LED is now off, I will again block the Genie sensor beam, and the alarm represented by the red LED will turn on. Regarding the Genie sensors in this bench test, with the sensors closer together versus the field test with the Genie sensors further apart, other than internal resistance differences inside the Genie sensor when the sensors are further apart, the length and gauge of the wiring can also affect voltage differences. After a brief delay, the red LED will turn off, representing the security system auto resetting. If you like this video, or just learned something in this video, please click like on the YouTube page below this video. Thank you.